In an alternate dimension, light years away, lives a universe much like ours, but different in one critical way. These people use data in ways of horror unheard of. This is the Statistics Zone.
Finally, this night I can test my calculations in experiment. I want subject Frankenstein become alive. That is great success. Average Frankies come alive is 30%. I want to find that more than 35% of Frankensteins are born over 100 trials. Igorita, show me to my board. Now I need to check assumptions and conditions. First one, 10%. Since I have 100 people I do the test, this is 10%, greater than 10% of total population. Check. Now, next condition, success/failure. I need to test whether success is greater or equal to 10 with my trials. I have 100 is N, 30% is B, and B is 30 greater than 10. Check. Next I have NQ, N 100. Q is 100 minus 0.30, 0.70. 70 is greater than 10. Check.
Statistics!
Okay, next we have to find standard deviation for experiment. We have equation square root PQ over N. We put success 0.30, failure 0.70, and N equals 100. This equals standard deviation 0.0458. Our normal model is shown with mean of 0.30, standard deviation 0.0458. No check. Next, we find z-score. Z-score is our proportion we want, 0.35, minus average 0.30, divided by standard deviation 0.0458. This equals 1.09. Finally, find proportion that we are greater than 0.35. This equals 0.1378. 13.78% of Frankenstein have great success.
He's a lie! My experiment is a success!
Now, Frankenstein, finish Igorita off!
Whoa. Oh no. Oh my god! Oh my god! Ah!
So what's the probability that Evan will die from watching The Ring? Our standard proportion for this would be that 50% of the time he would die from watching The Ring. We assume that all of the subjects watching The Ring are independent and that we're taking a random sample, and it's less than 10% of the population. Our success-failure conditions would be that 1,000 times 0.50 is 500, which is greater than 10. and 1000 times 0.50 is 500, which is also great for the test.
Now let's look at the null hypothesis that Evan will survive or die after watching the movie. So according to our null hypothesis, Evan will die 50% of the times after watching the movie. Therefore, null hypothesis P is equal to 0.50.
And how about the alternative hypothesis? P would be less than 0.50. So that means I'll have less than 50% chance of dying. Please, let's hope for that. Now let's start the test.
Now let's start the test. So first of all, we need to find the standard deviation. For that, we'll multiply the probability of success with the probability of failure over n and square root the whole thing. That will give us 0.0158. After this, we'll find out the z-score, which is p minus p hat over the standard deviation, which is 0.6 minus 0.5 over 0.0158, which gives us a z-score of 6.3291. Our alpha level is 0.01. So after running the test, we come across the p-value of 1.275 into 10 raised to the power negative 10. As the p-value is very low and it's lower than the significance level, we'll reject our null hypothesis and therefore accept the alternative hypothesis. So therefore, the probability that there is considerable evidence that Evan will die, the probability that Evan will die watching the movie is less than 50%. But wait, we can have a type 1 or type 2 error here. Type 1 error here would mean that the null hypothesis was true, but we mistakenly rejected it. But type 2 error could be, the type error could mean that the null hypothesis was false, but we failed to reject it. In both cases, the consequences will be very dire, and Evan will have to suffer.
Now, if we were to run the same test, but with means instead of proportions, we have a different set of assumptions and conditions and a different test to run, a t-test. Now, the assumptions and conditions for a t-test are the nearly normal condition, where you would look at the histogram to see if its shape is nearly normal. The randomization condition is whether or not the sample was collected randomly. The large enough condition is actually based on the one taking the test. They have to see whether or not the sample collected was large enough. Now, the null and alternative hypothesis for this test. The null hypothesis, mu d, or the mean of death, is equal to 50, is the null hypothesis. The alternative is that it's less than 50. Now for the test. The mu of Evan's deaths, or the sample that we collected, the average, was 40. The standard deviation was 22, and we took 1,000 samples. Now, if we were to run the test, it's to find a t-value, it's mu e, or the mean of Evan's death minus the average mean of death over the standard deviation of the mean of Evan's death. And that's 40 minus 50 over 0.6957. And that gives us a t-value of negative 14.3. Now, to calculate the standard error of that was S, or that sample standard deviation over the square root of the number of samples. That was 22 over the square root of 1,000, which gave us that value. Now, when we calculate the p-value, it's less than 0.00001. And that means that we drop the null hypothesis and accept all alternative hypotheses, that the mean of deaths is less than 50. Another way of remembering this will be told to us by Siddharth.
Basically, if the P is low, you drop the hoe.
And now we are going to learn about the very last concept in statistics, the chi-square test. Okay? Now you learn. Listen to her.
There are 3 types of chi-square tests.
1. Goodness of fit. 2. Test for independence. And 3. Test for homogeneity. Better learn them fast.
But as always, we will start with collecting data.
All the time.
I'll be back, baby.